Guys, welcome to MoBileMaThS with Kamchiran. Today we want to look at rotation in geometrical constructions too. Okay, so let's say I've got a unit square like the one that I have there, and it has got its vertices as 0, 0, 1, 0, 1, 1, and 0, 1. Okay, so with that information, when we are doing our rotation, I'm going to be concentrated on the sides that are on the x-axis and on the y-axis. So with that, looking at this square unit square, I'll have on my y-axis is small letter a there on the a side, small letter c on the c side. With those information, I can write a matrix in the form of a, b, c, d, where I'll be taking that this first column, the first column represent x-axis, the second column represent y-axis. Then these values on the first row, they represent values, and the second one y values. Okay, so I'll write my matrix denoting what is happening on the y-axis and on the x-axis as I'll have this as my x-axis, which is C, and A is on the y-axis. So taking point, I'm taking point C there, the one that I'm highlighting here. What do I have? I've got 1, 0. Then I go to A, I've got, it's the same as the vertices that I'm just taking and writing in the column vector. I've got 0, 1. Okay, like that. So this matrix that I've generated is an identity matrix. This is an identity matrix. So whenever we have a matrix that is going to be rotated with origin as its center of rotation, we have an identity matrix as our rotation matrix will be an identity. Okay, like 1, 0, 0, 1, like this. Okay, with that information, let's move on. I want to rotate that unit square, so I'm going to draw it again. So this is my unit square with A, B, C in center there, and I want to rotate it through 90 degrees. Okay, so that's the 90 degrees that I'm going to rotate it. So with that unit square, I can rotate and have my unit square forming on this point, where C comes from this point on the x-axis to this point. I'll have it as C dash. B becomes this one. A becomes this one. Okay, so remember we said we're going to concentrate on the terms or values that are on the y-axis and on the x-axis. So our small letter a is now here, our small letter c is now here. So I can write my matrix as remember we have C and A. Okay, so I can write my matrix as my C is now on 0, minus 1. My A is now on 1 and 0. Okay, so this automatically becomes the matrix that we use when we are rotating through 90 degrees about the origin O. Okay, so that's the first method. I'm going to show you the second method of calculation. Okay, so when we are calculating, I'm taking the same item. Remember our initial position for A was, its unit vector was 0, 1, of C was 1, 0. Okay, then after rotation, our A was now on 1, 0, and our C after rotation was now on 0, minus 1. Okay, so I'm going to use that information. Now, let me use again that matrix A, B, C, D, so that we want to find the values of, we want to generate this matrix of rotation using our initial and our final rotation value vectors that I have there. Okay, so R is just representing rotation there. It's just representing rotation. Okay, so with that information, I can have, I'm taking for point A, I can have A, B, C, D multiplied by our initial position was 0, 1. Okay, then we got the final thing was equal to 1, 0. Okay, now with that information, we can now do our row by column matrix multiplication, and we can get, let's do our row by column multiplication and see what do we get. We'll get A times 0 plus B times 1, and on the bottom I have C times 0 plus D times 1. Okay, like that, being equal to 1, 0. Okay, so I'll have my B at the end there, and I have my D there. Okay, so these are equal to 1, 0, meaning to say our B is 1 and our D is 0. Okay, so we can do the same for C. We can do the same for C. Let's do the same for C. For C, we have our A, B, C, D. Initial point of C was 1, 0. Final point was 0 minus 1. Then I do by my row by column. I will get, so I'm just gonna go straight to the answer there, otherwise it's straightforward. I'll get my A and C being equal to 0 minus 1. Okay, so at the end of the day, the matrix that I'll get combining all of those items, the number that I have, I'll have my rotation matrix in the form of A, B, C, D as 0, 1, minus 1, and 0. So it's similar to what we had generated earlier on. Okay, so this is the matrix that we use whenever we want to draw a rotation through 90 degrees. Let's go to the next one where we are rotating through. Now we want to look at rotation of 180 degrees about O. Okay, so what we do here, I'm not gonna I can redraw this. Let me see if I have a graph here. Okay, I can redraw. So we had it from here, our A, B, C. Okay, then we rotate through 180 degrees, so it will come and be formed here, and we'll have our, if we rotate and rotate there, we'll have our C2 here, our B2 here, and our A2 here. Remember, we are concentrating on C and our A there, those two sides. So with that information, I can quickly write the matrix that I have. C, and for A, I can have my matrix as minus 1, 0, and 0, minus 1. So this is the matrix of rotation through 180 degrees. Okay, this is through my method. Then we can use the method of calculating. I can do that. Let me do that. The method of calculating, I can have it as now, because I'm multiplying rotation, it can be for 180 degrees, I can call it r squared, because it's gonna be 90 and 90. So with that, I can have my 90 degrees matrix multiplied twice. So I'll have 0 minus 1, 1, 0, by 0 minus 1, 1, 0. I multiply those two. So I'll have here row by column. I'll have 0 plus minus 1 at that point, and I'll have 0 plus 0, here 0 plus 0, and here I'll have minus 1 plus 0. Okay, so adding at the end of the day, I'll have my r squared as minus 1, 0, 0, minus 1, which is similar to what we have generated. So this is the matrix of rotation through 180 degrees. Okay, so you can use whenever it's about the origin. Okay, now let's look at matrix when we are rotating through 270 degrees. So I can draw here. This is our A, B, C. When we rotate through 270 degrees, this is 270 degrees, we will form our square there, and we have our B3 here, our C3 here, and our A3 here. Okay, like that. So this is what we have. And remember, we are concentrating on A side, A side and C side. Okay, so I can formulate my matrix in terms of C and A as 0, 1, minus 1, 0. Okay, so this is the matrix of rotation through 270 degrees. Okay, let's do it through calculating method. Through calculating method, I can have it as r cubed. Okay, so if it's r cubed, it can be as r times r squared, and I can have my r is 0, minus 1, 1, 0, by r squared, the one that we got for 180 there, it is minus 1, 0, 0, minus 1, like that. Okay, so if we multiply this one, we will get we can do our row by column. We'll get 0 plus 0 here. Then on the other end, we have 0 plus minus 1. And here we have 1 plus 0. And we have 0 plus 0. Okay. So we can simplify this and have, at the end of the day, we can have, if we simplify this, we will have, let me write what we have on the bottom there. Okay, we will have 0, 1, minus 1, and 0 there. So this is the rotation matrix when we are rotating through 270 degrees. Okay, so we can do the same for 360 degrees when we want to rotate through 360 degrees. So when we do for 360 degrees, I can simply say r to the power of 4, that's for 360 degrees, is the same as r times r cubed, or we can say it's r squared times r squared. So when you do that multiplication, I can take first, let me just take n of the 2. I can have it r to the power 4 as 0 minus 1, 1, 0 by 0, 1 minus 1, 0. And if I multiply there, I'll get an identity. Remember, for the first one, we got an identity. So this is how you get the matrices of rotation through 90, 180, 270, 360. Let's just summarize and write them all together. So for 90 degrees, we have got our matrix is 0, minus 1, 1, 0. For 180 degrees, we have got minus 1, 0, 0, minus 1. Okay. For 270 degrees, we have got 0, minus 1, 1, 0, like this. Okay. Then for 360 degrees, we have got an identity matrix. Okay. 360 degrees, I've got an identity matrix. Okay. So we are going to use these when we will be doing calculations, or when we will be drawing transformations through rotation and about the center. Or otherwise, bye bye guys, let's meet next time.